And it's something different. Last time we did all the z-scores. So this is 3.3. Remind you where we're at. This is 3.3, part 2. We're going to finish up section 3.3. This is the last thing. And then we'll go over the practice exam. So 3.3, part 2. So basically, they're giving us a bunch of numbers here. It's cell phone data speeds. Anyway, and they're asking us, find the percentile of 3.8. This was brand new. We didn't do percentile. I didn't even show you the lecture on 3.8. I mean on percentile. I think it's better that I just explain it as we go, probably in the interest of time. So what is percentile? Let's talk about the word first off. Does anybody know? You know, they use it all the time, like if you have babies and you take them when they're born at the doctor will tell you your little daughter, your little son is at the 27th percentile or 83rd percentile for weight or height. Or if you take some big standardized test, SAT, big tests like that, they'll tell you come in at the 53rd percentile. Now it's kind of like percentage, but not exactly the same. Does anybody already know? What is percentile? What if your daughter is at the 23rd percentile for height when she's, 10 years old? They do it, every time you go to the doctor with your kids, they tell you the height and the weight percentile. So what if they tell you your daughter's at the 23rd percentile on height when she's 10 years old? What does that mean?
It's like below average.
What's that?
Below average.
Right? So what specifically does it mean? It is certainly below average.
Like it's a certain...
What does the 23 mean?
I don't know, 100 kid, she's 100 kid, 20, she's a 23rd percent. So I guess whatever is above her, like maybe 70, what?
Exactly. 23 is below, and the rest are above. Yeah, so specifically, you guys are right on the money. It means percent below. So let me write that out real clear. That is what percentile means. It means percent below. So if your daughter's coming in at the 23rd percentile for height, so percentile means percent below. So remember, it's always below, less, under. So yeah, if your daughter's coming in at the 23rd percentile for height, that means 23% of all kids her age have a lower height, which means whatever, 77% of kids her age are taller. Exactly. So percentile is percent below. So for example, what if you take a big test like the SAT or something, and you get a 60 percentile? Yeah, is that a D? Did you do terrible? No, that's actually not bad, right? 60% did below you. So what it is, it's comparing you to other people. So it's not that you got 60% of the questions right or anything like that. It's just compared to other people. It's always a comparison thing. So if you scored at the 60 percentile, that means 60% of the people did worse than you. So you're above average, right? 50 percentile be right in the middle. Does that make sense on that? So if your child comes home from the standardized tests in school and you see they got a 60 percentile, don't ground them. They're doing above average. That's good. That's good. That's above average on that. So making sense on that? So percentile is percent below. Okay. So therefore, let's go to the actual question now. They are asking us, find what is the percentile of the score 3.8. So they mean, if you can see that list, go up and find the 3.8 right there. And they're saying, if that's your phone's data speed, these are data speeds, right? If that's your cell phone's data speed, 3.8, what percentile are you coming in if these are all the data speeds in the neighborhood or whatever? What percentile are you coming in at?
Because you got to take the... Are you asking us?
Yeah. How would you do it? What do you do? Eddie, what do you think?
Any number that's below 3.8.
Yeah.
And then you divide that by, say there's 50 digits altogether.
I think there are.
So you divide say you got 3.8, and there's 10 of them that are less than 3.8. You get 10 divided by 50.
Exactly.
And you times it by 100, I believe, or to get the percent, if you want.
Or just move the decimal. Exactly. That's exactly it, because it's saying percent below, huh? Yeah. It's exactly what they're asking. Is what percent is below 3.8? So yeah, I think there's 50, aren't there? Isn't that 10 rows of 5 or?
Do you
include the 3.8?
It's easier to do that.
Yeah, good question. You do not. It's those below. Really good question. Yeah, those below. So that would be, so this is what, 30, and then 31, 32, 33 below? I think that's, they're all
I
in.
do it on stack and sir, it'd probably be easier for me
Yeah,
to
thank you
list.
so much.
Yeah, oh, Stack Crunch, you just pop up real
That's
nice.
why I did it
Yeah,
on
that's
stack crunch, and then I put them in numerical order from a. Like,
Oh, by saying this was due, I got you guys to work ahead and you learned all this stuff. That's great.
yeah, I did.
I should always do
I was on
that.
it yesterday.
It's all due on Monday.
Yeah. Yesterday it wasn't.
Yeah, right. Yeah, good. Yeah.
Not only that, I'm trying to interact so I can like get the hang of this.
So it's 33 out of 50. Does that make sense? Out of the 50 times, 50, what's it called? Data speed times. 50 data speeds, 33 are below. So divide that in your calculator. You'll get 0.66, but we always have to change it to a percentage. How do you change that to a percentage? Twice, yeah, times 100, moves the decimal twice, 66%. So what's your percentile? 66. That means you're at the 66th percentile. Your cell phone's above average, 66% or below. Make sense? On that? Percentile, percent below. All right. Yeah, so you want the ones below, not the number itself. Does that make sense? It's percent below, just the ones that are below. All right. Let's try number 7. Same kind of thing. Yeah, 30.
What if the number is two of those same numbers?
That's exactly what we got here, huh?
Yeah.
Yeah. So this one's 0.7. So which is right here and right here. So we're supposed to figure out what percentage of all these numbers are below. So we don't include either one of them. We just include the ones below. Yeah, good. Right. Is this all making sense? So we're just going to include that top row. Right, which is, what is that, 10 out of 50? 10 out of 50, which is 0.20, which is 20%. So 20 percentile. Is that good? So that the 0.7 is at the 20 percentile mark. All right, let's try it. So now we're going to change gears on number 8. We good so far? All right, so percentile means percent below. Now we're changing gears on number 8, and they're saying find the 90th percent. See, that's a different question. See, that's a P with a sub 90 instead of just saying percentile of. They're actually saying, tell us the score here. Which score, which data speed, is at the 90th percentile? They're asking a different question now in number 8. In fact, let me get you a bigger screen here. There we go. In number 8, they're saying, find the data value that's at the 90th percentile. So basically, they want me to find the score that has 90% below it. Well, I'm going to give you a game plan for that. I'll probably write it on the board as well. In fact, let me just go to the back here and show you. So it's a little bit of a tricky process. Find a percentile. Oops. So you're probably going to want to write this on your 3x5 or 4x6 card for tomorrow. No, Monday. And here's how it would go. You take the P percentile over 100 times N. Call that L.
What's L?
I'm just making up a name. It stands for locator. I'll explain how it works. But so first off, you take the percentile, like in this one they gave me 90, right? Take 90 over 100 times N. Now what's in? What's in all the time in statistics? You getting the hang of it yet? Number of values. Yeah, 50 in this case. But I want to give you a general formula first off. So you take the percentile you want, like in our case 90, over 100, that just makes it a decimal, right? 0.90, times 50 values. You get that value, but then here's the tricky part. There's 2 things that can happen. Case 1, if L equals a decimal, if L equals a decimal, like 2.3 or sorry, let me change it. 7.3. If L comes out to be a decimal, round up Do you know there's a difference between rounding up and rounding off? I'm not saying go to the nearest. I'm saying I would round that up to 8. Does that make sense in that, Nerdy?
So, but in,
No, I'm doing the same plan they are. Oh, is it?
it says do not round though.
No, that's something different. I'll explain. So you round this up, and then you grab. Oop, I can't write with this crazy thing here. Grab the 8th value. That's the locator, not the answer. That's why we're calling it L. That's like if you do any programming, that's the pointer. It's pointing to where the right answer is. Grab the 8th value. Grab the 8th data value in the list. Does that make sense? So if you get a decimal like 7.3, you round it up 8 and then grab the 8th. That's a locator. So I would go to my list of numbers. I go 1, 2, 3, 4, 5, 6, 7, 8. Grab the 8th one. That's the answer. And we'll do that in a second. But I want to give you case 2 first off, and then we'll start cranking through both of them. Case 2, if L is a whole number. In other words, not a decimal, like, I don't know, 12 or whatever. You know, no decimal. If it just comes out clean, like 12, then you have to do something tricky. You grab, it's a G there, grab the 12th and 13th. Grab 2 numbers in that case. 12th and 13th data values. And average them. So there's 2 different game plans depending on what that L thing comes out to be. Question.
Is it always going to be the one above it then? Like for 20?
What's that?
Is it always going to be the one above it?
Yes.
If it wasn't a 13, if it was
Right.
something else.
It would always, it's like if this was, yeah, it's always this and the next one.
Okay.
Yeah, it always is. Yeah. So those, yeah.
So if I got 40, it just stays at 40, right?
So let's do some examples. I think it'll make sense if we do examples. So everybody got that copy down? Is that good? In fact, actually, you know what? I'll write it on the board as well. Let's, oh yeah, it's back here. Let's go back to the questions. Number 8. Okay, so let's try it now on number 8. And I'm going to write this one. We're going to take 90. They want us to find the 90th percentile. So you take the L will equal P over 100 times N. So that's 90 over 100 times N. There's 50 data values there, huh? So, isn't that 45? Doesn't L equal nice, clean 45, right? No decimal. You with me? So what do we do when L comes out a whole number, no decimal? We take that spot and this. We take the number in the 45th spot. So that means we're going to take the 45th and 46th numbers and average them. So how do you know where that is? Well, this is 41. Remember the bottom row, it goes 10 per row? So 41, 42, 43, 44, 45, 46. Take those 2, add them and divide by 2. Average those 2 numbers. Leonardo.
It's number 8, not number 2.
Oh, whoops. Thanks. I got down on the wrong problem. Thanks. It's supposed to be up here. Yeah. So up here, so it's 41, 42, 43, 44, 45, and 46. Oh, that's convenient. It's just going to be 12.8 because it's the same number twice. So the average is 12.8. So the answer to this question is 12.8. That is the 90th percentile.
Are we going from left to right? 1 row, 2 rows, 3 rows?
We're going from lowest number in the data value, in the data set, to highest, which they did organize them left to right. Does that make sense? So now, see how these data values go up
Yeah.
from left to right? And they start over, and there's 10 per row. So this is 10, 20, 30, 40, 41, 42, 43, 44, 45, and 46. So I got those. So when you calculate your L, P over 100 times N, 90 over 100 times 50, came out 45, you get a whole number, you take the number in that spot and the next spot. Take those two numbers, add them and divide by 2. In this case, it's just going to be 12.8. Because it's the same number twice. Is that good?
How did
Question?
you get the next spot?
How did I get the what?
The next spot?
It's just literally the next one in the table. So this is I'm just counting them across. There's 50, there's 10. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 across. So it's 10 in the first row. You're right. So I'm just counting the rows. There are just 10 across as we go. So the first of this is 10 numbers here. And this is the next 10. That's 20 numbers. 30 numbers. 40 numbers, and then this is number 41, 42, 43, 44, and here's 45 and 46. So I just grabbed the 45th and 46th numbers.
Since it's the same number, you keep the same number, you don't add them, or...
Well, what's going to happen if you add them and divide by 2? You're going to get 12.8.
And that's what I was doing.
Yeah, I mean, go ahead and add them if you want and divide by 2, but you'll just get 12.8.
Then you add them and
Yeah, if they were different, yeah.
if it was 12.1 and 12.8, then you add them and.
Right, because you're getting the middle of it. You're getting the average.
And I was adding them yesterday, and,
Oh, you were dividing by 2?
yeah, and I was like, wow.
Gotcha. That makes sense. You're getting the middle of those two is what you're doing. You're averaging this. All right, let's try number 9. Should we try number 9? Oh, it says Q3. Yeah, I haven't explained that yet.
Is that third quarter?
It is. Just think about a football game. We just had the Super Bowl, right? So at the end of the third quarter, I don't think the Rams had they had 3 points. End of the third quarter, what part of the way are you through the football game? 3 quarters. How about in percentage? No. 75%. Yeah, that's just a fancy way to say P75. That's all that is. End of the third quarter, 75% of the way through. So they're asking you to find P75.
Then you just use 75 over 100.
Exactly. Use that formula exactly. So put it 75 for P.
I know.
So put in that 75. See if you can get it. Check with those around you.
So you round up 38?
Yeah, this one comes out at decimal, huh?
Yeah, 37.5?
Yeah. So you round it up. Exactly.
338?
Yeah, so we do the formula. L equals P over 100 times N. P is 75, right? Into the third quarter, 75% of the way through the game. Over 100 times 50. Yeah, does it come out 38.5? That what it is?
37.5?
37.5? So yeah, so what do we do when it comes out at decimal?
So you round up.
Round up 38. But a lot of times people mess up this way. You guys with me? Hear this for a second. This is what I've seen over the years. People will do a good job. They got this formula on their card. They crank it out. They go, oh, yeah, I got to round up. 38. There's my answer.
No.
Hold up. Why? 38's not the answer. 38's the pointer. Right. That's why I keep writing. That's the locator. Now go find the 38th number. Does that make sense? Don't forget that last step. All these things are locators. That's why they're called L. It's just telling you where to go. It's not the answer itself. It's like your address. Right? You wouldn't say, I'm Mr. 6380. That's just my address. That's how you locate me. Right? So this is just a locator. It's an address. Now go find it. Brian? Yeah?
Is it 37.5 or 3.75?
Yeah, 37.5? 75 over 100 times 50? Oh, wait. Oh, yeah, that's right. That's right. I'm doubting myself, too. Yeah, it is. It is. Yeah. Anyway, so go find the 38th number.
8.8?
So where's that going to be? There's 10 numbers in the 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. So the answer is 10.1. That's the number at the end of the third quarter. 75% of the way. See, and it looks like it's 3/4 of the way through the data, doesn't it? On that? Yeah.
So, what if the number's the same? Like, there's two numbers beside it, like.
Oh, that's okay. We don't, we just grabbed the 38th number. Doesn't matter what else is around. Yeah.
Cause like, easy way to do it, like, I don't know, like, we were just discussing it. Like, for instance, like, just ask quartile 1, and like, there was 50 numbers. So I just put 4 divided by 50 was, they give you 12.5, so I figured it was a 13th number in the series of numbers.
Yeah.
And then right now, we were asking quartile 3 for another question.
Right.
So you put 75, what, you put 75 divided by what? By 100, so it gave us like the 30th number. It was like 37.666 or whatever.
Yeah.
But we chose the 38 number.
That's right. Yeah, you guys are thinking right.
Like that.
That's exactly the same thing. You're basically doing that formula just a little more casually. Yeah, that's exactly it. You just divide by 100, you're finding that spot. Just remember, if it's a decimal, round it up, grab that. But if it's a whole number, you got to take two numbers and average them.
If it's a whole number?
Yeah, so do you understand that other part? Like we did a minute ago, right? So when you do that calculation, like look back at number 8. See at number 8, we got, when we did the 90 percentile.
Because the n might not always be 50, or an even number will, n might be a 38.
Yeah, it came out a whole number. See that, Eddie? The last one, number 8, when I did it, it came out, it didn't come out a decimal. It came out a perfectly clean 45, whole number, no decimal. In that case, you don't just go grab the 45th number. You actually grab two numbers in that case. That's the distinction I'm showing in the rules.
So you grab what, 13.4 and 14?
You grab, it was up here.
Oh.
Those two numbers. You grab the 45th and the 46th numbers,
Because it was a whole
both.
number?
That number and the next number, because it was a whole number. Yeah, so that's the difference. So
And if they're different,
use this on that.
those ones that came out the same because they're 12.8, 12.8, 45, 46 are the same, so that's the average number. But if it was 12.1 and 12.8, then you add them and divide them, that would be your number.
So how are we doing? Is this make? Let's do 11. It's asking us for P60. So try that. So here we go. So it says P over 100 times N. That's our locator. So 60 over 100 times, again, there's 50 numbers. So I'm getting 30. So that came out a whole number. What do you do when you have a whole number? Spaghetti, huh? I ate spaghetti as I was driving here tonight.
You didn't spill any?
I did. I have that green jacket, so it's pretty clean. Yeah, so what do you do when you get a whole number? That number and the next one, right? You with me? And then average them. Yeah, so I'm going to grab the 30th and the 31st, and I'm going to average them. Right? Is this making sense? So where's the 30th number? This has got to be the 30th. It's into row 3, huh? Let me do it better. Right? Because there's 10 per row. So that's the 30th, and this is the 31st. So I'm going to go 3.6 plus 4.6 divided by 2. It's just the middle of those two. So that's going to be 4.1. 4.1. 4.1, is it good? Is this making sense?
Yeah.
Is everybody okay? We're having a little bit of talking. I'm fine with that as long as, can everybody focus okay? Is everybody able to, is this working for you? Let me know. I want to be a beneficial environment for everybody. So is that good? Does that make everybody can follow and understand? Questions I can answer? All right. I'm going to move on. Yeah, good. We made, that was the hard thing. The rest, this will be calculated. So here we go. Here's the box plot. So number 13, basically they say, here's some radiation absorption rates, not in cell phones, blah, blah, blah. They say the 5-number summary is, your TI will give it all to you. In order, 5 numbers. Just type these into your list, put those values into L1 on your calculator, and then I'll show you, or maybe you remember from before, automatically all 5 numbers that you need will come right on out. So let me Well, I want to write it out for you. So here, I'll leave this up. Yeah, one more time, Val, you got him? What was it?
0.51, 0.84, 1.19, 1.36, 1.48. 1.48. So that would be A.
Well, I'll show you how it looks. Everybody getting those numbers first off, out of your TI?
How do you get that?
So those 5 numbers should all come out in a list after you do the one variable stats.
I would say 18.
Okay.
So are you getting those? Oh, did it? 0.51, 0.84?
That's supposed to be 50. Because those are like halves on the 5.5.
Yeah, I know. I've got this crazy pen. I can't write very well. 0.84?
But I think
Okay, so I'm going to show how it works now. What you do with those is you put them on a box plot, meaning this is the end of the thing. This is the box, like that. This is here. This goes up to there. That's how the box plot works.
Okay.
Meaning the lowest value is the dot at the end of the line. And then this is on this line, the middle's in the middle, this is on this line, and the dot at the top. Am I making any sense? So in other words, and let me tell you what these are. I haven't even told you what these are. Basically, this is taking all of the data and breaking it into 4 nice sections. Again, just like a basketball or football game. Breaking it into 4 quarters. Because this is Q1. This is Q2. This is Q3. This is the minimum, lowest value in the data set. And this is the maximum, highest value in the data set. In other words, 25% of all the data is right in that chunk there. Y'all seeing what I'm saying? A box plot, what it does is it's real convenient. Say that education officials want to know how the high school kids that graduated last year are doing on the SAT. They could take like 10 million scores, or however many it is, from all the high school kids in the United States. And they could have 5 numbers that would show you how all the kids are doing, meaning it would break all the data, 10 million numbers, into 4 nice even chunks. And you would know that 25%, 1/4, of all the high school students are between 0.51 and 0.84, even though those aren't the right numbers. And the next 25% are between 0.84 and 1.19. The third quarter is between those two, and the fourth quarter is between 1.36 and 1.48. Does that make sense? It quarters data. It takes a whole bunch of data and breaks it into 4 even sections. Yeah, these are quartile blocks. So I want to look at these box things now and tell me which Q1's at 0.84. Which Q1 is at 0.84? Yeah, it's looking like C, isn't it? Do you see that? Because this, I don't know if I can write that small. This is 0.6, 0.7, 0.8 is right there.
The beginning of the line starts 0.51. Beginning of the line.
Is that making sense? How are we doing? Does everybody see that C is going from a left edge? This left edge here is about sorry, I can't write very well, 0.84. And this edge is about 1.36. And this looks like it's about 1.19. See how that is? So the box goes from the second number to the fourth number, the Q1 to Q3, the left and right edges of the box. Is that making sense?
So when we do the bob, we're just considering the
Oh, yeah, and the stem goes down and up to the lowest value, 0.5. See how this goes all the way down to the 0.5? The box itself, so there's the box, and then there's the stems that go above and below the box.
Yeah, I'm gonna try it.
Is that good? See how that's C there? Do you want me to make that bigger? I don't know if I can without losing all the numbers. Yeah, so a 5-number summary, is everybody getting that down? Is a min, a Q1, Q2, Q3, max. Breaks the data into 4 pieces. All right. I better move on. Same thing here. I'm not going to do nothing. Just type them all in, hit the buttons on your calculator, and find the right graph. Is everybody okay with locating the graph? Do everybody see why it's C there? Right? Do you see, again, want me to talk about that for another minute? Do you see the main thing you look at is the left edge of the box and the right edge of the box should match this number and this number. The very lowest number is where the stem, or some people call it box and whiskers diagram, where the whiskers end, and this whisker goes to about 1.5. That's right, that's almost 1.5. And then the box goes between 0.84 and 1.36. So this looks like it's about 0.84. This edge here looks like it's about 1.36, and this middle looks like it's about the true middle, 1.19. It's supposed to be a 9. So it breaks the data into 4 quarters, is what it's useful for. That's why people use it. Is that good? We okay? All right, I'm going to move on. That's the same thing. All right, let's fill in the blank. Whenever a data value is less than the mean, what's true? It's considered to be significantly low. The corresponding z-score is positive. The corresponding z-score is negative. We do not consider it. Yeah, negative is correct. Whenever a number is less than the mean, less than the middle, right, below average, then its z-score. Remember what z-score is? Do you have a feel for z-score? Number of standard deviations above or below. Positive above, negative below. So we'll go over that in the practice exam. We'll see some questions where they ask us the feel. We did a formula last time for z-score. I'll put it on again as we go through the practice exam. But z-score is number of standard deviation jumps, right? Above or below the middle. So we'll talk more about that in the practice exam. Last question. Which is not in the 5-number summary? Yeah, mean is not there. Is median there? Yeah, it's the same as Q2. Q2 is another name for median. Because what is Q2? Into the second quarter. What's the end of the second quarter called? Halftime. Halfway through the data. That's what a median is, huh? Yeah. It's the same thing. Q2 and median are synonymous. So yeah, so the only one that's not there is mean. So is that good? Let me go back one more time to z-score. So again, z-score is number of standard deviation, SD, standard deviation jumps from the middle. It's the number of jumps you are from the middle. Remember I talked about if they grade on the curve, if you're right in the middle, you get a C. If you're 1 standard above, you get a B. 2 standards above, you get an A. Right? So now remember what standard deviation is. Typical distance from the middle, right? So say you take an exam, there's an average, but not everybody's right on the average. Some people are above, some below. How far above average or below average you are, that's, typically are, then that's the standard deviation. It's typical distance from the middle. So z-score is how many of those standard jumps. So if your z-score is real high or real low, you're very deviant from the middle. Really great or really bad. Right? Does that make a little more sense? We better move on to the practice exam.